Hello, good morning students. So in yesterday's class we have finished till question number 7, and in today's class we'll start with question number 8. See, using the properties of determinant, I hope you people are clear with the properties, right? And then the elementary rows and column operation, right? Okay, using the properties of determinant, find x. So from this determinant I'm asked to find the value for x. Please look at the elements in the first row, x plus c, xx. Second row also x plus c, xx. Third row also x plus c, xx. I hope you can see something common. Columns also x plus c, xx, x plus c, xx, x plus c, xx. So hence either you can go through columns or either you can go through rows. Okay, so for now I'm going through rows. The operation I'm using out here is using R1 as not only R1 plus R2, but I can also take R1 as R1 plus R2 plus R3. Please note down the operation which I am using out here. Pause the video and then try to understand why am I using this. Okay, as we move ahead then you'll understand why am I using this operation. Okay, R1 as R1 plus R2 plus R3. So which means all the elements of the first row, all the elements of first row is going to be changed now. It is going to be changed as in this way, R1 plus R2 plus R3. So R1 will be, my new R1 will be, the first element will be this plus this plus this. The second element in R1 will be this plus this plus this. And third element in R1 will be this plus this plus this. Which means this. And there's no change in R2 and R3. There is no change in R2 and R3. So which means this. See, by the way, we are asked to find the value for x, and this is an equation. So eventually we'll be getting an equation. So this is determinant equals to 0. It's given in the question. Okay, so using this property, using this operation, I'll be getting R1 plus R2 plus R3 as this. There's no change in R2 and R3. R2 and R3 is same as the question, but R1 has been changed according to this operation. Okay, now if you see properly, then this is 3x plus c, this is 3x plus c, and this is 3x plus a. Isn't it not? Which means this. 3x plus c, 3x plus c, 3x plus c. This is the same. The reason I have used this operation is now because I am getting 3x plus c common in the first row. 3x plus a common in the first row. Okay, please do note down what I am telling. 3x plus a is common in the first row, so I can take 3x plus a common. So the basic difference between now, the basic difference between a matrix and a determinant is that in matrices I used to take common throughout the matrix, isn't it? But in determinant, either particular row or either a particular column. So out here, I am taking 3x plus a common only from R1, not from throughout determinant. Okay, so taking 3x plus a common from R1, and you have to mention like this: taking common 3x plus a common from R1. So 3x plus a will be outside of determinant. And the first row becomes 1 1 1, that is 1 1 1, and then the second and the third row is as it is. I hope you're clear till here. Okay, so the first part of the question is done. So now we move to the second part of the question. So pause the video to note it down. Alright, so this was the last step that we got, taking common 3x plus a, and then this is the remaining determinant. Now what should I do now? So many of the students would directly expand from R1, no problem, you can do expansion also, but instead of that, what am I doing is, I can do expansion also from R1, but instead of that, I'm going to decrease the elements in R1. Okay, how? Just check now. See, this is 1 1 1. Now what if I use C2 as C2 minus C1? C2 as C2 minus C1, this becomes 0, and C3 also as C3 minus C2 or C3 minus C1. All in all, what I'm trying to do is I'm trying to make this 0 and then make this is 0, because this is 1 1 1. 1 minus 1 is 0. 1 minus 1 is also 0. 1 minus 1 is also 0. If I do that, then it will be very, very easy for me to expand from R1. Okay, which is the next step. So the next step I'm taking out here, C2 as C2 minus C1, C2 as C2 minus C1, and C3 as C3 minus C2. Okay, so the second column will be changed and the third column will be changed. Column 1 remains as it is, which is this now. 3x plus is already out here. There's no change in column 1, but there's a change in column 2 minus column 1. So column 2 minus column 1, corresponding elements are x, 1 minus 1, 0, x plus a minus x is a, x minus x 0. So column 3 is changing as column 3 minus column 2. This minus 1 minus 1 0. This minus this is minus a, and this minus this is a. Determinant close, which is equals to 0. So now if you see properly, now this determinant is very easy for us to expand as comparable to this determinant, isn't it? So what am I doing now is expanding from R1. Now you know how to do expansion. The signing conventions will be plus, minus, plus, expanding from R1. This is outside. So within the box bracket, 1 into, neglect the corresponding column, neglect the corresponding row, remaining determinant, minus, see 0. 0 into anything is 0. So I'm not written out here. Plus 0 into anything is 0. Okay, so that's the reason whenever you have 1, 1, 1 in a column or 1, 1 in a row, always try to make 2 of the 1 as 0. Okay, like this. Now it's very easy. Okay, that is this minus this is a square plus 0, right? So this into a square. So a square go this side. So 3x plus a equals to 0. So hence what is the value for a? Sorry, what is the value for x? X equals to minus a by 3. See, one sum I'm taking a very, very long time because there's explanation. There's a whole lot of things going on. So please do pause the video and then try to understand. Alright, okay. So that was question number 8. Even though the explanation was very long, okay, we have to understand, isn't it? So question number 9, I'm giving you homework. Same type of question. I'm giving the hint as R1 as again R1 plus R2 plus R3. You'll be getting x plus a plus b plus c as a common factor. Okay. So that you'll do yourself. Now I'm moving to question number 10. In question number 10, the question says, without expanding, prove from this determinant to this, and this is equals to this. Okay, read the question once again. The question says, without expanding, prove this is given to us. So 3 determinants we can see, right? So I've given as the first one as first, the second one as second, and third one as third. So all in all, what I have to do is I have to prove first to second and second to third. So we'll first prove from first to second. See, the first determinant is this. So write the first determinant. This is the first determinant, isn't it? And I have to prove from this to this determinant, isn't it? No, this one is this, this one is this, and I have to prove from this to this. So let us compare what is the difference in the first and the second determinant. Even though the elements are same, but they are just a difference in the columns and rows, right? So just see the positions of x. Okay, by the way, so when you're proving from one determinant to another determinant, the second determinant, first element, please check the first element of the second determinant, which is x out here. So I have to get x in the first row, first column. Okay, and I'm starting with this determinant. So my x is out here. Anyhow, I have to get the value for x in the first row, first column element, A11, isn't it? So how will I do that? How can I do that? I can only do that by interchanging row 1 with row 2. I can only get x out here by interchanging row 1 with row 2. So that is my first operation. So using R1 goes to R2 and R2 comes to R1. So we know that from property number 3, if 2 rows and 2 columns are being changed, then the value for determinant changes with a minus sign, isn't it or not? Sorry, that is property number 4. My mistake. Okay. So hence from this determinant I am using R1 to R2. So R2 comes to R1 and R1 goes to R2. So there will be a minus sign. And see the difference from here to here. See the difference, The second row is going to the first row, X, Y, Z, and the first row is coming to the second row. Only change in R1 and R2. R3 is as it is. Isn't it or not? I hope you're clear till here. Pause the video. That was by property number 4. And now again you see, I got X, Y, Z. I got X, Y, Z in the first row, but I'm not getting A, B, C in the third row. In fact, it is in the second row. And now what to do again? Again, now you interchange R2 to R3 and R3 to R2. Simple as that. Okay. So by interchanging R2 to R3 and R3 to R2, again there will be a minus sign. So that is this. This minus sign is already there. And I'm changing R2 to R3. Again there will be a minus sign. See, R1 I have kept as it is. R1 I have kept as it is. So there will be a change in R2 and R3. So this and this changes. So entire R3 becomes R2 and entire R2 becomes R3, which is this. So there's a minus sign. So minus and minus, which is plus. So hence this is this, which is this determinant. Okay, so hence I have proved from first to second. First to second is done. So now we'll prove from second to third. So pause the video to note down. Now second to third is also very similar as first to second. Okay, so second to third, I have to prove from this to this, right? This to this. Okay, now let us see what is the difference from this to this. My x is out here and y is out here. But in the third determinant, I have to prove y as a first row, first column element, isn't it or not? But my y is out here. So what will I do? I'll interchange column 1 with column 2, interchanging column 1 with column 2. Okay, so if I'm doing that, there'll be change in the minus sign. So that is the first step. C1 goes to C2, C2 comes to C1. I'm talking about this determinant, and this we are proving. So I'm using C1, C2 in this determinant. There'll be a minus sign now. So there'll be a minus sign. The second column comes as the first column. It might be confusing to you all, but practice it again and again. It'll be very easy for you all, okay? So this comes as the first column and this goes as the second column. There's no change in the third column. It remains as it is. Clear? I hope you're clear with this. And now again you try to compare. I got x, y, z, but sadly my x, y, z is not in the first row, but it is in the first column, sorry. I have here in the first row, but it is here in the first column. So what will I do? I can interchange rows and columns, which means I can take the transpose of this determinant, and this is my property number 3. When the entire rows and columns are interchanged, the value for determinant remains as it is. That is your property number 3. Please do check your properties again. Interchanging rows and columns by using property number 3. It remains as it is. Minus sign remains minus sign. Okay, the only thing which changes is the first row becomes the first column, the second row becomes the second column, and then the third row becomes the third column, which is this step. I hope you're even clear with this. And now you try to match what we are getting now. Okay, see, I got the first column x, y, z, but yes, there's a difference in the second and the third. If I interchange this and this, then I'll be easily getting this. So hence, what is the last step? The last step will be interchange C2 to C3, C3 to C2. Again, there will be a minus sign. Remember that I'm changing 2 columns at a time. I'm not changing the entire rows and columns. Okay, I'm only changing column 2 with column 3. So there will be a minus sign. So minus sign is already there, into minus. So now what we get is this and this will be interchanged. So minus and minus will be plus, right? It will be plus, and this is your determinant number 3. So hence, all in all, I have proved from first to second and then from second to third. So pause the video to note down. Alright, now we are moving to question number 11, part 1, which is 2018. Okay, solve for x. So solve for x is the question given to us. Now so far we have done this type of questions. So we have got some ideas now slowly. So just look at the elements x, a, b, c. X, a, b, c. X, a, b, c. So pause the video and think which operation you can use. Okay, you might be getting 2 operations in your mind, either R1 plus R2 plus R3 or either C1 plus C2 plus C3. You decide what you'll use. I hope you got it. So now the operation out here is R1 as R1 plus R2 plus R3, not C1 as C1 plus C2 plus, C1 as C1 plus C2 plus C3, not R1 as R1 plus R2 plus R3. So the operation I'm using out here is C1 as C1 plus C2 plus C3. Why? Because I'll be getting x plus a plus b plus c, x plus a plus b plus c, and x plus a plus b plus c if I add these 3. Isn't it or not? Okay, you verify yourself. So I'm changing column 1 as column 1 plus column 2 plus column 3. The moment you do that, all the elements of column 1 will be changed. There's no change in column 2 and column 3. It remains as it is, which is this. Column 2, column 3 same, but column 1 will be changed as column 1 plus column 2 plus column 3 in the corresponding elements. And if you see it properly out here, there's a common thing, x plus a plus b plus c, x plus a plus b plus c, x plus a plus b plus c, which is this. And now what I'm doing out here is I'm taking x plus a plus b plus c common from first column. Okay, that is this, taking x plus a plus b plus c common from first column. After I do that, I'll be getting this. I'm not doing anything in column 2 and column 3. It remains as it is. The only thing I'm doing it is in column 1. And why am I doing? You also know that because we need to find the value for x. It'll be only easy to find the value for x if I try to take out common and make one of the columns or rows as 1, 1, 1. We have also done in the previous sum, isn't it? So now what you do from this step, you take the transpose. I'm taking the transpose, property number 3, because the property of transpose tells us that if I take a transpose, the value for determinant remains same. There's no change in the value for determinant. Okay, so this and this, they're same. The only thing that changed out is the rows have become columns and the columns has become rows, right? So far so good. So pause the video to note down. Yeah, this was the last step now. So what should I do now further? I already have 1, 1, 1. So try to make 2 of the 1 as 0. Use the same old property, C2 as C2 minus C1, C3 as C3 minus C1 or C2, right? So which is this? C2 as C2 minus C1, C3 as C3 minus C1. All the elements of C2 and C3 will be changed. The value of C1 remains as it is. Even this common factor is same. So C1 is same, but C2 and C3 is changed out here in this way. You verify yourself. C2 minus C1, 1 minus 1, 0. This minus this x, this minus this a minus c. C3 is changing C3 minus C1. This minus this 0, this minus this 0, this minus this is x. You can also do C3 minus C2 also, huh? Please be careful. The only thing is that if you are changing C3, C3 has to be there. If you're changing C2, C2 has to be in first. Okay, and now we're simply expanding from R1. Okay, we'll be getting this. We'll be getting this step. So either x square equals to 0, so x equals to 0, or this is equals to 0 means x equals to minus a plus b plus c. And this question is same as question number 9. Question number 9 also, huh? So please do the same type in the same way in question number 9 also. Huh? Question number 9 is very, very similar to question number 11 part 1. So pause the video to note down and try to understand. Now as we move ahead in question number 11 part 2, a similar type of questions you will be getting. Okay, even the elementary rows and column operations are also similar. Just we have to make 1, 1, 1 in any row or any column. Okay, so question number 11 part 2, I have given the hint out here. Please do follow the hint. I'm sure that you will be able to do this question. Very, very easy, right? And then question number 12 part 1 also. Number 12 part 1 also, the hint is given out here. Okay, so if I do all these questions and explain in the video, it will be very long. Okay, so I'm trying to make it as short as possible. It's already 17 to 18 minutes right now. Okay, so please do follow the hints. I'm sure that you'll be able to do. Okay, and the hints also for this is given out here. Number 12 part 1. Everything is given out here after taking common, the operations. You just have to verify yourself. Okay, and then finally you'll be getting this, and from here you know what to do. Okay, use and then expand from here. Okay, so that's it for today, and your assignments will be, your homework will be question number 9, question number 10 part 2, and question number, okay, I'll just write it. Alright, the assignments will be question number 9, question number 10 part 2, question 11 part 2, and question number 12 part 1. Right, so still a long way to go to complete this exercise, so do it properly and regularly. Okay, and then very soon we'll complete this exercise 4.2, which is the very longest exercise in this chapter. The rest of the exercises are very, very easy. Okay, so hope to see you tomorrow.